Okay guys, today we're here to talk about the conservation of matter. The law of conservation of matter says that matter cannot be created and it cannot be destroyed, but it can be rearranged through the breaking and the forming of bonds. So if matter is anything that has mass and takes up space, if it cannot be created and it cannot be destroyed, if we have something that undergoes a chemical change, can there ever be a change in mass? Well, let's check it out. Today we're going to look at zinc and hydrochloric acid reacting, and we saw this in a previous demonstration, so it's nothing new, but we're going to use a balance to kind of check out what happens. Okay, so here is our zinc, mossy zinc, and here's our hydrochloric acid. I am actually going to create a closed sealed system using this balloon. I'm going to pour the zinc into the balloon. Okay, so it was kind of a messy pour, but what we can feel in here, you can't see it, but I poured the zinc inside of the balloon, and then I'm going to go ahead and I'm going to put the balloon over top of the Erlenmeyer flask. Okay, so the balloon's on top. We now have a closed sealed system. We're going to come over here to our balance that's reading 0.00 grams, and we're going to put the Erlenmeyer flask with the balloon and zinc on top. Now what we're going to do is we're going to tip the balloon upwards and allow that zinc to go in and react. Okay, so we can see the mass is staying relatively the same here. No matter has been created, no matter has been destroyed. So our balloon is filled with hydrogen gas, which is made up of tiny particles that have mass. If we take the balloon off and we create an unsealed system, what do you think is going to happen to the mass? Okay, so when we remove the balloon from the flask, that gas, hydrogen, made up of tiny particles that have mass, they're able to escape to the surrounding environment. So what happens is there's a decrease in mass on our balance. Does that mean the hydrogen was destroyed? No, it just means that the hydrogen is no longer tangible to us. It's no longer massable. So let's check out how we make a particle diagram that represents a chemical change, upholds the law of conservation of matter, yet allows for the change in mass. So these were the reactants, zinc and hydrochloric acid. When we mixed them together, they underwent a chemical reaction. Matter is not created, it's not destroyed, so what we see is that we have the same number of green filled in circles on our reactant side as we do on the product side. Okay? We have the same number of unfilled circles on the reactant side as we do on the product side. And then we have the same number of filled in circles on the reactant side as we have on the product side. No matter was created, no matter was destroyed, and we definitely were able to observe this at the macroscopic level because we saw that the mass pretty much stayed the same. So here we have the same reactants, but instead of having a closed sealed system, we had an open system where the balloon actually was no longer attached to the Erlenmeyer flask. That allowed the hydrogen gas to escape. How we show that hydrogen gas is no longer tangible, no longer massable, is we show it here on the outside of the particle diagram box. That allows us to know that no matter was destroyed, it's still present, but we just can't reach it to take the physical mass of that substance. Okay, so here I have something called steel wool, and steel is basically an alloy or a mixture of two elements, iron and carbon. Okay, so it's a homogeneous mixture. What you can see is it looks the same throughout. What we're going to do is we're going to take a mass of our steel here. Sorry, let me just show you that it was 0 to begin with. And here we find that our mass is 7.83 grams. What I'm going to do is I'm going to take this steel, which appears, if you can't tell, shiny and silver, and I'm going to run it through the Meeker burner. Okay, so now we have the substance after it was put through the Meeker burner. It no longer really looks silver and shiny, but actually it looks more dull and blue. We're going to take the mass to see what happened. I think it was like 7 point something at the previous measurement. But what we see now is the mass is 8.10 grams. All right, so my question for you is, where did that extra mass come from? Can you draw a particle diagram that would show the correct change that took place and includes the conservation of matter being followed?